Sideboard! On Wednesdays, we wear pink on the 9th of December. Honors Geometry, you guys will be able to use side, 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 and side angle side, and SAS, to prove triangles congruent. Section 5.4. So we're going to talk about some ways to prove triangles congruent, okay? Well, hey, let's think about it this way, okay? Let me take these two triangles, okay? These two triangles, they are very perfectly drawn, as you can tell. Okay? Okay, take in the great artistic ability, okay, of these two triangles, okay? That's all we're doing with them. No, just kidding, okay? We're actually using them. Okay, let's say, okay, these two triangles have their corresponding sides are all congruent. Okay? Let's say their corresponding sides are all congruent. Okay? Now, is there a way we can change up one of the triangles to make an angle of different sides? Okay? Let's say right now, okay, all of the corresponding angles, are also congruent. We'll put the one arc away opposite the one tick mark, the two away from the two, and 3 are from the 3. So we know these triangles are congruent right now, right? We have all corresponding sides, all corresponding angles congruent. We see that right now, don't we? Yep. Okay, triangles are congruent. Now, is there a way I could change just the angle measures, but not the side lengths, and keep these triangles congruent?
No, because that's what the...
Probably.
Okay, Bill?
Yes, because of SSS and SAS.
No. Okay, let's look at this, okay? If I were to try and make this angle bigger, down on the bottom left here, I'd end up having to move where this side was, right? Instead of the side being like here, it's going to have to be going down farther, right? Kind of like a hinge. Okay, maybe like a door opening wider, okay? Now, when I open and close the door, okay, the angle the door makes with the door frame changes, doesn't it? Okay? Does the length of the door frame change? No. Does the length of the door change? No, okay? But the length between the edge of the door and the edge of the door frame changes, doesn't it? Okay, this part changes, okay? So as the angle becomes smaller, what happens with the angle, with the side length over here? Okay, it becomes smaller, okay? As the angle becomes bigger, what happens with the angle of this door frame? Or this the side of the door frame. This non-existent side that we imaginary see. It becomes bigger as this angle becomes bigger, okay? So, is there a way that we can keep this distance the same, the door frame the same, and the door the same, but change up the angles?
No.
I don't see a way. Okay? So, even as long as these three sides stay congruent, there's no other way to fashion the angles together. Okay, so even if I were to take an exact replica of that somewhere else, maybe even in the next room over, and we keep the door, the frame, and we have it open to this exact length between the frame and the door, would the other door and door frame and imaginary length, would it have the same angle?
Probably.
It would have to. It would actually have to have that same angle. We could go and actually measure that if we wanted, okay? But if we were to have this try and swing over, it's no longer going to connect here at the same length. It's no longer going to make that the same angle, okay? So what's going to end up happening is we have enough information to say two triangles are congruent if we even just know their corresponding sides are congruent. So we actually don't need to know, plot twist, we actually don't need to know all the angles and all the sides that correspond are congruent. We don't need to know all that information. We actually have a shortcut. If three sides of one triangle are congruent to three sides of another triangle, the triangles are congruent. That's enough for us to say that is the case. We can't possibly form any two triangles where all the corresponding sides are congruent to each other and they're not congruent. It's not possible. You can try all day long you want. It's never going to happen. So let's use this to our advantage to prove these triangles congruent. So let's look at letter A here, okay? We have a lot of measures going on here, don't we? Okay, it's kind of all clustered together. Okay, well, let's mark some sides congruent here. We're trying to determine whether the triangles are congruent. We don't know any angles, but we know some sides. What are some sides we can mark congruent?
12
Okay. 12 and 12. Okay, so side EH inside
No, it's.
oh, 12 and 12, excuse me. Side DH inside HF. Thank you. Side DH inside HF. Those are both 12 centimeters, 12 centimeters. Okay, what are another pair of sides that are congruent? Okay, Aiden. Okay, HG and HE, 24, haha. Okay, and what are another pair of sides we know to be congruent? Dominic?
ED and FG.
Yeah, side ED and side FG, 20 centimeters and 20 centimeters. Okay, I just marked them with 3 tick marks there. Okay, so now do we know all 3 sides are congruent here?
Yes.
Okay, and so now we know all 3 pairs of corresponding sides are congruent. According to SSS, side, 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 does that abbreviation SSS make sense to you guys? Side, side, side. Okay. We can say, hey, triangle EDH is congruent to triangle. If I call it EDH, what do I have to call the other one?
GFH.
GFH in order to correspond. Okay, I'm gonna say triangle EDH is congruent to triangle GFH by side, side, side. That's enough to show that they're congruent. That's enough. We proved the triangle's congruent. Is this a simpler proof than the 2 column proofs we were doing before? Okay. You guys saw proofs. You're like, ah, okay. It could be worse. Okay, that's enough to prove it. We're happy with that. We're content with that. We proved the triangle's congruent. And our reasoning is this: by side, side, side. And we can see in our picture, we know all the corresponding sides are congruent. So we end up having a shortcut here. Questions on this? All right, let's look at this second example. Letter B. What are you guys thinking on letter B? Do we think these triangles are congruent, Sarah?
No.
Why not?
Because the M and N and R and Q are not the same.
Yeah, we see this 28 and 32. Those aren't the same. Well, even though we do see side PN, side RS, side QS, side PM. But those other sides, those are not congruent. So I would agree with you. I would say these are not congruent. An explanation of your reasoning, you could just say 28 doesn't equal 32. You could also say, if you wanted, side MN is not congruent to side RQ. You could also say not all corresponding parts are congruent. Okay, you could also say, it can keep going on and on and on. Okay, Max.
So, you had that angle R is congruent to angle N and angle Q is congruent to angle M. Would that then be impossible for those two, like, different, for that to happen?
Yeah, wouldn't that end be possible?
You're saying, okay, let me make sure I got this straight, okay, so I can answer this question accurately. You said angle R is congruent to angle N,
Yes.
and angle Q is congruent to angle M.
Yes.
Okay, that could actually, no, that you're right. That actually could not be possible. Yep. We cannot have those angles being congruent to each other right now with the way the rest of the triangle is set up. It's not possible to have that. Yep. Okay. All right. Any other question on that? That was a good one. Good question. Okay. Let's look at letter C. Okay. Don't blurt. I want you to think about whether or not we could prove these 2 triangles congruent. And if we can, we'd want to put our congruent statement, which is the triangle this, congruent to triangle this, by our shortcut, or our CPCTC if you want, if you can. Otherwise, we say not congruent and explain why. Anna, what are you thinking?
Those are congruent.
Okay, how do we know this? How do we know these triangles are congruent? I only see 2 sets of congruent sides.
Because it's like connected. I don't know how to explain.
Okay, what side are you looking at here?
G and J.
Okay, GJ. Okay, well that's shared by both triangles, right? So what do you have marked on your picture?
The line.
Okay, you have it with 3 tick marks here. Are you saying that GJ is congruent to itself?
Yeah.
Okay, so how do we know something's congruent to itself? Reflex property. So we can use the reflex property here. Now do we have three sets of corresponding congruent sides congruent? It's going to be corresponding congruent sides. Three sets of corresponding sides congruent. I was redundant there. So we can use the congruent statement. Okay, Anna, how do you have yours labeled? Triangle what?
Triangle KGJ.
Okay, and so you did triangle KGJ to start. How do you have it finished off? Triangle.
Congruent to triangle LGJ.
I like it. Triangle LGJ. Okay. Did you guys have to have yours in the same order as Anna did? No. Okay. But your second one has to match your first. Okay. So for example, you did GJK. Your second one has to follow the same order GJL. Okay. And by SSS side. Okay. As it alludes to on the board and in your note packet, we're going to learn other shortcuts as well. Questions on that? Okay. I was going to try and lick my finger to help me get to the next page of the notes, but I can't lick my finger because El Masco. Okay, let's go back to this door example. Okay? Let's say we're into this door frame. That's not changing, is it? Okay? Length of this door, that's not changing. We're not going to take like a saw to it. Okay? And let's say this angle that the door makes to the door frame, okay, this angle here right now is changing, right? Okay, it's closing and opening. Okay. Let's say the angle's not going to change. If I open up another door in the school, and I take out my handy-dandy protractor and I get it to this exact same angle, what are we going to know about the length between this door frame and this door? It has to be the same, doesn't it? It can't be different, could it?
Unless the door frame is too big.
Unless the door frame or the door is a different size, right? But assuming that the door frame and the door are the same, then and this angle is exactly the same, measured very carefully, then this has to be the same length, right?
Yep.
So then would we know all three sides are congruent?
Yep.
So then we would know the triangles are congruent again, right?
Yep.
So technically, we don't even need to know all three sides. We can know two sides and one of the angles, right? Because that led us to the other information. Does that make sense to you guys or no?
Yeah.
Okay? Now, be careful. Did I just pick any random angle? No, I picked a very specific angle. Where was the angle I picked? At the door? It was between the two specific sides, right? It was between those two specific sides. Which leads me to SAS, side, angle, side, triangle congruence. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So the angle we're talking about here has to be between the two congruent sides we're talking about, the two sides we're talking about of each triangle. That's why it's included, it's between them. And if you notice, even as we see it written here, where is the A located? Between the S's in the middle. Okay, and that's for a reason, that's on purpose. Okay, the order, that's very important. Because as we go around the triangle, we have like side, angle, side, angle, side, angle, side. Okay? And as we look around the triangle, we're saying the side, the angle, and the side would be congruent between these two doors. Aiden. We'll talk about that. Okay? Not only is that a naughty word, we'll talk about why that doesn't work. Okay? So determine what Aiden, okay? Determine whether these triangles are congruent and explain your reasoning, okay? So let's look at these two triangles, okay? On letter A. Do we think these two triangles are congruent?
Yes.
Okay? Well, let's talk about it. So we have JK and MN are both congruent. They're both 74. JL and MP are both congruent. They're 46. And the angle between them, angle J and angle M, are both congruent. So is this two sides in the included angle congruent to two sides in the included angle?
Yep.
Yeah. So like with our door, the other one has to be the same length. Has to. So can somebody help me write a congruent statement for this? Okay. Max. You can look like you kind of have your hand raised, and I'm going to assume you did.
But what?
The congruent statement, like triangle this, this, this.
Wait, the reasoning or like the?
Like the triangle this, this, this is congruent.
Oh, sorry. Triangle J L K.
Okay.
M P N.
I would agree with that. Triangle JLK is congruent to triangle MPN. Now, you didn't have to have your first one in that order, but if you do, the second one has to be in the same order, okay? By, and now what's our reasoning this time? Not side, side, side. Saren?
Angle side. Sass.
SAS. Side, angle, side. Saren's good at SAS.
I'm very sassy.
Questions on that first one? All righty. Not all lefty, all righty. Let's look at number B. Number B. Not letter B, but number B. Okay?
That's a big word. I don't like it.
B?
Reasoning.
The was the big word.
Yes. All of them are big words.
What's the reasoning?
I don't know how I passed third grade math.
I still don't know that.
I passed kindergarten.
You know that when you write like
It's
this.
so funny. I was actually driving the other day, and the worst thing ever. So my person took me driving. They're like, "Make a right turn," and then I almost turned left. And then they're like, "Why?"
Shameful, shameful, shameful. All right. Letter B.
We all know you do it.
Letter B. Okay. What are we thinking? Are these two triangles congruent or no? No?
43 does not equal 45.
Okay, 43 and 45, those aren't the same, okay? Well, okay, because between 20 and 19, which are congruent sides, the included angle, not congruent, okay? So these triangles are not congruent. And you're right, the reasoning could be 43 is not equal to 45. What could be another set of reasoning? Bill?
You know, I think if you look hard enough, 43 equals 45.
Maybe if we look hard enough and switch to a different form of math where everything's not correct, okay?
Yeah.
Angle A is not congruent.
Okay, angle A is not congruent to angle D, okay? Very good. You can also say the included angles are not congruent if you wanted to go like fancy smancy, okay? There's lots of different ways you really could explain this, okay? Questions on that at all? Let's look at example C, but don't blurt, please, and thank you. Okay, raise your hand if you have the answer. Silent killer, I'm going to pick on you. What do you think this is?
I think it's congruent.
You think they're congruent? Alrighty, I'm going to agree with you. So give me the congruent statement.
Triangle EDF
Awesome. Triangle EDF is congruent to triangle HGJ. That could be one way you phrase them. By SAS, side angle side. Side ED and side HG are congruent. Side DF and side GJ are congruent. And the included angles D and G are congruent. Questions on that? Of the Y?
No, not that.
Oh, okay. Sorry, I'm used to answer. What was your other question? You have a question on the previous slide?
No. No, why won't work if it was angle side side?
Oh, yes, we'll get to that. Like, actually, we will. Like, but, yeah, it's a naughty word. Okay. Yes, we'll get to that in a bit. Okay. Yes. Okay. So not only is it a bad word, okay, it actually just doesn't work. Okay. All right, let's continue this. We're almost done with this lesson, guys.
Oh,
Yeah. Not too bad. Could be worse. Okay.
You have to do 5.5 too.
Not today.
no! Well, I'm review.
No, saying it's not going to change what I was going to do.
I mean, don't put
Okay, I think there is gullible on the ceiling.
Liam.
Oh, whom?
I don't see anything. Liam.
Okay.
I saw
I
you.
guess you won't.
Use the given information to justify why each pair of triangles is congruent. So on letter A, we're going to do letter A together. I want you to try to do letter B on your own after that, okay? Letter A. We're given that segment BD is the perpendicular bisector of segment AC. Wait, what does perpendicular bisector mean? Okay. Intersects at right angles, that's the perpendicular part. So angle BD forms a right angle with AC on both sides. They're both those would be right angles then, right? If one of them's a right angle, the other one is too. Okay. Now what's the other part of that word? Bisector mean? Yes, Liam.
Splits it down the middle.
Splits it down the middle. So
B, DC are
Okay.
congruent.
AD and DC are congruent. Okay, so we know those are congruent. Now wait, do we have enough information to say these two triangles are congruent like it's trying to tell us they are?
Not really.
Yes.
Yes. No. Yeah.
Not really, and yes, Gage, why do we have enough information if we do?
Because like two of them are already the same. I just said yes because that's what I thought.
Oh, okay. Let's go with Bill.
Because BC could be longer and like more hours than BA.
Okay, so you're saying they might not be congruent. Is that what you're saying? Okay, so Bill's trying to reason against it, okay? He's saying maybe they're different lengths. Okay, Liam, what are you thinking?
BD is equal to BD.
Okay, BD is congruent to itself, right? So wait, do we have enough information now?
Yes.
Okay, wait, what information do we have?
Sass.
SAS. We have two sets of corresponding congruent sides, and we have their included angles. Are both right angles? If they're both right angles, are they congruent? Yeah. So we can say, so using information to justify, okay, well, triangle BDA, it already gives us a congruent statement, so we can just use that one. It's congruent to triangle BDC by SAS, side angle side. Questions on that one? So we had to use the information it gave us, and then one extra piece of information we got from looking at the picture. Didn't we? That might be something that happens on letter B as well. Okay, go ahead and try letter B. All right. So we have some information on number B. Okay, as Aiden reminded me that it's number, not letter. Okay, we're told that segment CD bisects segment AE. So what can we know if segment CD bisects segment AE? Okay, Aiden. Okay, that AE is being cut in half, right? So what two segments are congruent then if AE is cut in half? Israel? AE and AB and segment BE. Very good, okay? Now we're also told segment AE bisects segment CD. So what information does that give us? Very good. Segment CB is congruent to segment BD, okay? Now is this enough information, two sides? No, but rock, paper, scissors. Rock, paper, scissors. Okay, Max.
The B, angle B, how am I saying this?
Angle ABC.
Yeah, well, angle ABC is, yeah, right there, that one, is then congruent to the one to the right of it. On the right, yeah, that one.
Okay, angle DBE.
Yeah.
3 letters, vertex in the middle. Okay, and by what? How do we know those are congruent?
Because of the,
They're vertical angles. The vertical angle theorem tells us, hey, vertical angles are congruent 100% of the time. So now, is this enough information to prove these triangles are congruent?
yes.
Yeah, triangle ABC is congruent to triangle EBD. It would be SAS. Two sides in the included angle. Questions on that? Now, hey, hint. Next semester we'll recap this, okay? Next semester we're going to be taking a test over some of this material. We'll review it a lot, don't worry, okay? You might need to mark information on your picture in a problem like this. Just a thought. Okay. Anyway, we're going to end it there.